For this activity, you'll need some height data. In this example, I've got some student data. His parents recorded his height from the time he was 6 years old up till 16 on the kitchen wall. So the student has measured that off the wall and turned it into a table. The other thing you'll need is GeoGebra. I would recommend version 4. Version 3.2 or higher will do, as we're going to use the spreadsheet function. So the first thing we'll do is to fire up the spreadsheet window, which is here, and enter our data. So it's just a very routine entry, and I'll just get that quickly pre-loaded. And the last one is 5. Now there are actually 2 more data points that we can get in. We know that at negative 0.75 years, we know that our student was size 0, and at 0 years when they were born, just did a quick look on Google to get an estimate for the average length of a baby boy, it's 50 centimeters. Okay, so now we have our data loaded. The next step is to get these points into our graph. So we highlight the data and create a list of points, and there we have it. So I'm just going to close the spreadsheet view for a second and zoom out so we can see our data. Here come the points, and I'm going to do a little bit of manipulation by putting my mouse on the axis, holding down the control key. I can spread it out a bit. There we are, there's our curve. Well, there are our points. So the first thing we can do with this data is to put some line segments between it and see what we get. So I'm going up to here, hit that little thing down, get line segments, and I'm just going to join the points. And now we can immediately see we've got some very different rates of change. What we can do is we can go to our gradient and just see those changes. And in fact, right here we can see there's where the growth started. Here we were having a rate of 6 centimeters per year. Here we're at 10 centimeters per year. But it looks like the most phenomenal growth rate happened around here before we were born, which is what we'd expect. So at this stage we can have a discussion about rates of change. Now let's make it more interesting. I'm going to take all this data off. We'll do something different. Okay, so I've removed my line segments. Now we're going to try something different. Now if you have GeoGebra 4, you have a little button down here which will give you a list of all the functions. If you don't, that's okay, you can type the function in by hand. We're looking for a statistics function called fitPoly. I'm going to paste that in, and this is going to try and develop a find a polynomial that fits these points. So I'm going to use that list of points. Let's go for a 7th degree polynomial and see what happens. Your student's probably going to immediately notice that this model predicts that he's going to start shrinking after about the age of 18, which would be a wonderful opportunity to talk about the limitations of modelling and what we might do to improve this model. If you like, you could also stretch the algebra window so you can see the polynomial that's been generated. Now notice it's got 0 to the power of 0 to the x to the 7th. That's a rounding issue. I can go up to options, change the rounding, raise it to higher precision, and then you'll actually see the polynomial in its full glory. Now the real reason we wanted a polynomial function here, well any function, is we wanted to be able to do this. Put a point on the curve, attach a tangent to the curve at that point, there it is, And now I can actually drag it over the function and watch how the slope changes. Let's also add gradient on there, on that function. There we are. So the first step is we can have a discussion, look at the actual value of that. You'll see it's here in the algebra window. There is the tangent value. Next thing we're going to do is we're going to color that tangent blue to make it very clear that this is the tangent. I'm going to add a new point on the GeoGebra screen. I'm going to edit its object properties. Now for this point I'm going to set it. Its x value will be the x value of point n. The x value of point n, like that, the x of the n. Set it to the x value of point n. There it is on the now on the x-axis, and demonstrate this, that as this point moves, it tracks. And finally what we're going to do is we're going to take that point, rather than set it at the 0 y value, we're going to set its y value to be the current slope. And so now what we see is that as the slope changes, so does the point move. For the pièce de résistance, and to see it very clearly, we put a trace on, and now as we move it, there's our gradient function.